So in this lesson we are going to look at the properties of materials. So the learning outcome, so students should be able to investigate the properties of different materials including solubilities, conductivity, melting point and boiling point. So the first thing we want to think about is what's known as a solution. So a solution it has what's called a solute and it has a solvent. So what are these things? So a solution is a mixture of a solute and a solvent. Okay, so a solution. A solute is a substance dissolved in another substance. So for example, if we were to take a beaker, so imagine we have a beaker like so, and in that beaker we put in, so we add in some salt. So NaCl, sodium chloride, and imagine then we add in some water, for example. So we add in salt and we add in water. We add in water, which is H2O. So imagine inside here we have loads of salt. We just added in loads of salt, okay? So this together, the whole thing together is called a solution. So this is salt and water, solution. The majority of the substance that is in the solution is water, so that's what's called the solvent. And the stuff that we put into it then is what's known as the solute. In this case, it's salt. Okay, so this is an example of what's called a solution. It's a salt and water solution. So a solution is going to have a solute, and then it's also going to have a solvent. So a solvent is the liquid that dissolves a solid, liquid, or gas, or dissolves the solute. So water is a solvent, and the salt is the solute, and together they make a water. So they make a salt or saline solution. Okay, so what we can say is that we can dissolve salt in water, or another way to think about it is that salt is soluble in water. In other words, when I put it in here, it'll mix in with the water and it'll go into the water. Now, so we can say that it's soluble. Now, in contrast to that, if I had, for example, imagine we had a beaker, and inside the beaker I was to put in some water, just like what we've done here. So we put in some water, and then if I was to add in, so for example, instead of putting in salt, if I was to put in oil, so imagine this is oil. So what's going to happen is, so we have oil, and then we have water. So oil is insoluble. Okay, so in other words, it doesn't mix in with it doesn't mix like it does here, like the salt mixes with the water. So it's what's called insoluble. So it's insoluble. In other words, the oil will just sit on top of the water. It won't actually mix into it. When I take the salt and I put it into the water, it'll disappear and dissolve into it. Similarly, if I could take, for example, if I'm making a cup of tea, I can take the sugar and I can dissolve it in the hot water. It'll disappear into the solvent. In this case, would be water. So that's a solvent, and then the parts of a solvent, or a solution, should I say, and parts of the solution. Now, what can happen then is if I was to keep adding in salt and keep adding it in and keep adding it in and keep adding it in, it's going to get to the point where the salt will not go into the solution anymore and it'll actually start to come out of the solution and it'll sit at the bottom of the solution. Now, when this happens, we have what's called a saturated solution. Okay, so in other words, it's absolutely packed with solute. So a saturated solution is a solution containing the maximum concentration of solute dissolved in the solvent. So the additional solute will not dissolve in a saturated solution and remains as an insoluble material at the bottom of the container. So raising the temperature increases the amount of solute that we can dissolve before it is saturated, and solubility is the mass of substance that can be dissolved in 100 cubic centimeters of water at a particular temperature. So if I was to keep adding in salt, for example, into this solution, it will eventually, what will happen is the salt will start to build up. It'll stop going into the solution and it'll actually start to build up here at the bottom. Okay, so you'll get this. And when it's like that, it's what's called a saturated solution. So see the way here it talks about like a saturated solution. It's saturated with the solute, so no more will actually go in. Now what I can do is if I want to dissolve more solute into it, I can actually add heat. I can start to heat this up. So heat. And what that will do is that will basically allow this excess solute to dissolve into the solution. So it'll start to dissolve and it'll start to actually go into the solution, so by adding heat. So basically heating a solvent allows you to put more solute into it. So these are properties, for example, of solutions. So, and this here, this solubility is a property of the solvent that has been used to dissolve the solute. So solubility is the mass of substance that can be dissolved in 100 cubic centimeters of water at a particular temperature. So a way to kind of think about substances is we can think about it from a solubility point of view. So for example, we might measure out 100 mils. So 100 mils of water. And then we might take our substance, so our solute, and see how much of this we can dissolve, how many grams, for example. So remember, grams is the mass. So how much of the solute we can actually dissolve into the water. And different substances will have different solubilities. Okay, so this is what's known as the solubility. So different substances will have different solubilities. And this can be used as a way to identify different materials or different substances. So some substances are really like you can dissolve a lot of mass or a lot of grams of it in 100 mils of water. And then other substances like oil, for example, none of it will dissolve into the water. So that's a way that you can distinguish one material from another. We can use this property of what's called solubility. And what we can do is, and we will do this in the lab, we can look at the solubility of copper sulfate. So copper sulfate is just it's a material that it has this blue color when you dissolve it in water. So we can use a Bunsen burner, a tripod, and then this copper sulfate. We can have a beaker with some water and a glass rod to stir. And what we can do is we can start to add in the copper sulfate and stir it into the solution. So we can measure out how much of the copper sulfate we can put in. And what will happen is you can get a table that's like this, and this looks at the solubility of copper sulfate. So the mass of copper sulfate that dissolves at each temperature is shown below. So for example, at 20 degrees we can get 32 grams of copper sulfate into 100 mils of water. And then if we want to get any more, we have to increase the temperature. So we can see here that as we increase the temperature, the solubility goes up. Okay, we're able to get more grams of the solute dissolved in the solution. And we can look at something like this. So this is what's called the solubility curve, or it shows the solubility of the material copper sulfate. So along the bottom we have temperature, okay, and along the top then we have solubility. So you can see that as the temperature increases, the solubility increases as well. And this, like by graphing, for example, the temperature versus solubility, it will give this distinct pattern for copper sulfate, and this can be used as a way to identify copper sulfate as a material. So what we can do then is we can use this graph and we can read information off it. So how much copper sulfate would dissolve at 70 degrees Celsius. So if we wanted to work out, for example, at this temperature, how much copper sulfate would dissolve, we can come across here, draw a line up, draw a line across, and then read off, for example, how many grams per 100 mils of water of copper sulfate will dissolve in 100 mils of water at that temperature of 70 degrees. And it's roughly about 72 grams. Okay, so we can see it here. Draw a line up, draw it across. So this is what's known as the solubility, and we can see that the solubility of a substance can change as we increase the temperature of the solvent. So different substances have different solubilities. So if we look at there's loads of different substances here. So this is salt, for example. This is sodium chloride. So these are different compounds, and we can see that each of them have this unique solubility curve. Okay, so this can be used as a way to identify different substances by their solubility. So what we can do is we can use this property of materials solubility to distinguish one material from another. So we can see here that these guys here have all distinct solubilities in relation to each other. So solid C is very different to solid B, which is very different to solid A. And we can see that here, for example, there's an overlap between these two, but on a whole, we can see that the solubility is very different at different temperatures. And that's also shown in this diagram here as well. So that's one of the properties of materials that you can look at, what's called solubility. So the next property then is materials have this ability to conduct heat. So different materials will conduct heat. So what's called thermal conduction is the transfer of heat from particle to particle from a hot area to a colder area. So basically what happens is if we take this here, so if we hold a material and we add heat to one side, what will happen is, so one side of it's going to be hot, the other side is going to be cold, and heat moves from the hot place to the cold place. So what happens is that if we were to zoom down into the atoms that make up the solid, we can see that they're all kind of tightly packed together like this. Now, when we add heat, they start to vibrate at one point and they hit against each other. And then what happens is that it causes the atoms beside them to vibrate, and then the ones beside them and the ones beside them. And that is what's known as the movement of heat. That's what actually happens when heat transfers through a material. So different materials will conduct heat to a different degree. And this is like solubility, it's a physical characteristic or a property of materials. So if we have a look at this example here, so conductivity is how well a material conducts heat, or how well it lets heat move through it. Some materials, such as metals, can conduct heat better than others, such as plastics. Okay, so we can have, for example, here is a pot of boiling water, and like if we put in, so here's a wooden stick, a wooden spoon, and it has butter on one side. Here's a plastic spoon, and it has butter on the top part, and here's then a metal spoon. So what we can see is that this one here melts first. Why does it melt first? Because the metal is a much better conductor of heat than the wooden spoon or than the plastic spoon, and that's why they put plastic on handles, and that's why they use wooden spoons as well to stir substances, because the heat doesn't transfer through it as easily. So that is another physical property of materials, how well they let heat pass through them, or how well they conduct heat. And what we can do is we can investigate this in the laboratory as well. So we can take, let's say, rods of different metals. So for example, you can have aluminium, brass, copper, iron, and then a drawing pin, so it's made out of wood. And you can put a little bit of Vaseline on each one, and then you can put a thumbtack on the top of each one. And then what you do is you start to heat up one end of the material, and then you count or time how long it takes, for example, the the Vaseline to melt, and then for the coin or the thumbtack to drop off. Okay, so that shows that different metals, for example, have different materials have different abilities to conduct heat through them. So we've looked at solubility, and then this is what's known as the ability of materials to conduct heat. So that's another physical property of them. Another property of materials are that some materials can act as really good insulators. So insulators basically do not let heat pass through them. So conductors allow heat to pass through them easily. Insulators do not let heat move through them. So insulators retain heat, and they are poor conductors of heat. So we can see here we have this material that's around the hot tank, and what that does is it stops the material, the heat getting out of the hot tank and passing into the air. So we can compare different insulators. So for example, we can use a thermometer, and we can have a bottle that's uncovered, a bottle with some aluminium over it, a bottle with cardboard around it, and a bottle then with styrofoam around it. And then over time, we can measure the change in temperature over time. And what we can see is that there will be differences in how much heat is lost, for example, from each of the containers based on the materials that are used to insulate them. So materials can be good insulators. That's another physical property of materials. The next one then is what's called electrical conduction. So copper and other metals are good conductors of electricity, and plastic is an insulator and it does not conduct electricity. So if we take, like copper, for example. So copper, imagine this is a piece of copper, and inside the copper you have atoms of copper. So you have copper. And its chemical symbol is Cu. So this is copper. And we have electricity. So basically electricity, if we think about the parts of the atom, so we have the electron. And if we remember, this is a negatively charged particle. So copper allows electrons. So imagine if this is an electron. Copper allows electrons to pass through it. So the electron will pass through it like this. It'll bounce off each of the copper atoms, and it'll pass out through the copper. Okay, so basically copper then is what's known as a good conductor. So conduction means that it allows the electrons to actually move through it. Now what we do then is we add an insulator. So we add a plastic, for example, around the copper wire on either side. So this is like a plastic cover. And this acts as an insulator. Okay, the copper is a conductor. Okay, so the insulator basically, if this electron tries to go out here through this insulator, it won't be able to, it'll just bounce back off it again. Okay, so basically insulators do not let electricity move through them. And when we talk about electricity, it just means the movement of electrons, the electron through it. So copper and other metals are good conductors of electricity. So plastic is an insulator as it does not conduct electricity. So this is what's happening in relation to things like metals like copper and plastics. They do not let electrons move through them very easily. So if they allow electrons to move through them, they're good conductors of electricity. If they do not let electricity move through them, they are poor conductors of electricity. And what we can do is we can set up a simple circuit like this. So you have a battery, you have a light bulb, and then you have the material that's to be tested. So this is what it looks like. And what we can do is we can break the circuit and we can put in the material that we want to test. And we can use this to identify whether a material is a good conductor or a poor conductor of electricity. So if we use an insulator, we put something that's an insulator in here, what will happen is the electrons won't be able to move through the insulator and therefore the bulb will not light up. If we use a metal, something that is a good conductor, it'll allow the electrons to move through it and the light bulb will light up. Again, if we use an insulator like a pen, the light bulb will not light up. And then if we use something like a conductor like a paper clip, the light bulb will light up as well. And this is something that we can look at and we can carry out in the lab. So the next kind of physical property then that we want to look at is what's called the melting point. So melting point basically means it's the melting point is the temperature at which the solid and liquid forms of a pure substance can exist at the same time. So it's the temperature at which a solid turns into a liquid. So if we take ice, for example, the temperature at which it starts to melt is what's known as its melting point. So it starts to turn from a solid into a liquid. So here, for example, are some common melting points of different materials. So the melting point of steel is 1510 degrees Celsius. So it takes a huge amount of energy to smelt or to melt steel, so as we can see here. So here are some of the other materials. So if we start at the bottom, so oxygen has a very low melting point and it has a very low boiling point. So the boiling point is where a liquid turns into a gas. The melting point is where a solid turns into a liquid. Okay, so we have these two temperatures. So if we look at oxygen, nitrogen, they have really low melting points and boiling points. If we think about alcohol, it has a fairly low melting point and it has a high enough boiling point. Water, it starts to melt when it's at 0 degrees and it starts to boil at 100 degrees. Candle wax melts at 50 degrees. It boils at 400 degrees. And then we have hard plastics. So we have lead, so you can see it has a very high melting point and boiling point. Aluminium, very high boiling point. Copper, iron, and tungsten. So if we have a look at this copper here, so this is why we use copper when we're using, like when we build like electrical circuits, we use copper. Why do we use copper? Because it has this really high melting point. So what happens is when the electron moves through the copper wire, it bounces against each of these atoms here. And when it bounces against the atoms start to vibrate and they actually start to get really hot. And basically the movement of electricity or the conduction of electricity through materials, it generates a lot of heat energy. And if for example copper didn't have such a high it didn't have such a high melting point, what would happen is let's say if it had a melting point like, for example, like candle wax, what would happen is the copper would actually start to melt. So it would, and therefore it wouldn't be very good then at conducting electricity. So when electricity moves through a substance, it generates a lot of heat. So therefore it's important that like melting points and boiling points are very important properties because like you don't want to, for example, make a saucepan handle out of candle wax because it's just going to melt. So it is. You don't want to use you don't want to use hard plastics in materials that are going to be in contact with temperatures over 240 degrees. So that's why these melting points and boiling points are very important that we understand them, because we use these materials to construct things in the world around us, and the properties allow us to use those materials to build those objects. And if we take, for example, the melting point of ice, we can actually track this. So we can set up an experiment and we can measure the temperature. So for example, and keep an eye on when the ice starts to melt. So what we will find is that like at really low temperatures, it's as a solid. And then as you start to heat it up and it gets to 0 degrees, what starts to happen is it starts to melt. So you can see there's this period here where the temperature stops rising. So at this point, this is where melting is happening. Okay, so you're adding heat, so the temperature isn't rising, but what's happening is that heat energy is going into moving the atoms that make up the water molecules that are really packed tightly together in ice and spreading them apart and it's causing the ice to turn into a liquid, or it's causing melting to happen. And then what will happen is once it starts to melt, then the temperature will start to increase again. Okay, but at this point, this is where melting is happening. So if we think about what's actually happening, so from a melting point of view, so imagine we have, so this is a solid block of ice, so a solid piece of ice. And if you were to like go in here and look at the atoms, what you'll see is that the water molecule atoms are packed really close, really tightly together like this. Okay, so it's as a solid. And then as you add heat to this, okay, so you're adding heat, what's going to happen is these water molecules will start to vibrate, and they'll actually start to move away from each other. And then what's going to happen is that's eventually it's going to start turning into a liquid. And basically what's happening is the water molecules are kind of moving, they start to free up, and they have the ability to kind of move across each other. So they have this ability to kind of, to move back and forth like this. And that's like kind of, they have the ability to flow, and that's what gives like water its characteristic. And that's kind of like what's happening. Now, so what are some of the things that you can do? You can actually take substances and you can put it into the ice, like salt, for example. And that's salt. So imagine these are really tightly packed together water particles. So these are water particles. So we have here and here. So if we can get these to move away from each other, then it's going to go from a solid into a liquid. And one way we can do that is we can introduce materials that will get in between the water molecules, like salt, for example. And that will lower the melting point, or it'll lower the amount of heat that you need to add to get the water molecules to separate away from each other. So melting point of ice. So if ice has impurities such as salt in it, it will melt at a lower temperature than normal. So salt is added to icy roads to melt ice at a temperature of -2 degrees. So that's why we add salt. That's why we salt roads, to get the ice to melt. Why does it get the ice to melt? Because it gets in between the water particles and it causes them to be able to separate. And when they separate, it goes from a solid into a liquid. And that's what we want, so that we can drive on the road. So then the next property then is melting point, you have what's called a boiling point. So boiling basically is, so if you continue adding heat to this, so you continue adding heat, what will happen is these particles will actually move further away from each other, much further away, like so. And when they do that, we get what's called a gas. Okay, so this is a gas. This is a liquid. And then this is a solid. And we have what's called evaporation. So evaporation is happening here. We have melting that's happening here. Okay, another word for evaporation is boiling. So it's basically changing from a liquid into a gas. So evaporation is the change of state from a liquid to a gas. So the liquid will start to boil off, and the particles will start to move out of the liquid and move further away from each other. And that's what you see when you see steam, for example, rising out of a kettle. So the boiling point of a substance is the temperature at which it changes state from a liquid to a gas throughout the bulk of the liquid. So the boiling point is like the amount of heat energy, or the temperature you have to get it up to in order for the liquid to turn into a gas. And again, going back to this table, so here are some of the boiling points, for example, of different materials. So we can see the boiling point of water is 100 degrees, whereas if we take something like tungsten or iron, it has a really high boiling point. It takes a huge amount of heat energy in order for you to be able to change it from a solid to a liquid to a gas. Even to change it to a liquid takes a huge amount of heat energy. So evaporation is the change of state from a liquid to a gas. the boiling point of a substance is the temperature at which it changes state from liquid to gas throughout the bulk of the liquid. And what you can do is you can carry out an experiment to look at to measure the boiling point of water. So to find the boiling point of water, so you record the temperature of water as it heats. So you basically set up, you can take a beaker of water and put a Bunsen burner under it and start to heat it up and put a thermometer in and start to measure the temperature as it rises up. So bubbles bubbles form vigorously when the water is boiling and the temperature stops rising. So what will start to happen is you'll see there'll be this rise in temperature and then it'll stop. The temperature will stop rising, and what you'll see is this formation of bubbles like this. So basically what's happening here is the liquid that's in the liquid water is turning from a liquid into a gas. And all of that energy is, instead of increasing the temperature of the overall solution, it's going into separating the particles. The energy, the heat energy, is separating the particles from each other, and it's changing state from a liquid into a gas. The temperature of the steam may continue to rise. So if you were to measure the temperature of the steam up here, the temperature will continue to rise, but here the bulk of the material, the temperature kind of levels off for a period of time, and then it starts to rise again. So this would be the way you kind of set it up. So you'd have water, you'd have your tripod, your Bunsen burner, your wire, water, thermometer, and then your beaker. So pure water should boil at 100 degrees Celsius. If it's not boiling at 100 degrees Celsius, if it's lower, that might indicate that there's some kind of impurities in your solution. If the water contains dissolved solutes such as salt, the boiling point will be slightly higher. And the interesting thing then as well is that the boiling point of pressure, so the boiling point of water is highly dependent on the pressure of the atmosphere around it. So at sea level, the still water boils at 100 degrees Celsius, so down here at sea level, it boils at 100 degrees Celsius. As elevation increases, the atmospheric pressure decreases and the boiling point of water decreases as well. So as you climb the mountain, for example, it takes less heat energy to change the liquid into a gas or to boil the water. And so if you look, so for example, at sea level, it takes 100 degrees Celsius of heat energy to boil water. As you go up to 6,000 feet, it takes about 93 degrees Celsius. And then if you go up to 10,000 feet, you're talking 90 degrees Celsius. So it lowers the boiling point. And a way to kind of think about that is that, so imagine this is your container here. So imagine this is your container, and in this we have like a liquid here. And as we add heat energy, so we're adding heat energy, what starts to happen is some of the particles have the ability to escape from the bulk of the liquid. Now, what's happening is that, imagine then it's inside an atmosphere. So imagine you have a big body of air, so it's the air that's all around it. And that air is exerting pressure, or it's pushing down on the water. So when you're down here, you have a huge amount of air above you that's pressing down on the water, and it's stopping the particles turning from a liquid into a gas. So it takes a lot of energy to overcome that. But as you go further and further up, this starts to decrease. So for example, here it might be like this amount of air that's pressing down on the water, and as you move up, it'll start to get smaller. So you might have something like this amount of air pressing down the water, and then as you go further, it reduces it even more. So therefore, it takes like less energy for the particles in the water to change from a liquid into a gas, because they're able to escape easily because of less pressure at higher altitudes. So that's kind of like the link between boiling point and pressure. And this can be interesting as well. So at high pressure, such as inside a pressure cooker, water boils at a higher temperature and so cooks food faster as well. So the idea of a pressure cooker is to reduce the pressure and that allows the much higher temperatures to be reached and allows the food to cook much quicker as well. So pressure cookers work in that way. Now what we have is this kind of a graph here as well. So this shows, for example, this process here that happens when you add heat to water, add heat to ice, and then it starts to melt. So what we have is, so along the x-axis here we have heat added, and then along the y-axis we have temperature. So you're measuring the temperature of the liquid. So it starts off as a solid, and what will happen is as you add heat, so imagine here you're adding heat to this solid, the temperature on your thermometer will increase, and then it'll get to a point where the temperature will not rise anymore, and this is the stage at which the solid is actually turning into, it's going from a solid into a liquid. And at this stage you kind of have, you know, some solid and some liquid, so you have melting happening. And then once it melts, it goes from here to here. Then what starts to happen is it starts to go from here to here. The particles start to move further apart, and that's what we get here. So we get the rise in temperature, and then all of a sudden then it starts turning into from a liquid into a gas. So we get this at 100 degrees. What's going to happen is we get this leveling off of temperature, and then it starts to turn into it. This is where it's going from a liquid at this point to a gas at this point, and then it starts to turn into a gas. And once it turns into a gas, the temperature starts to increase then as well. So latent heat is the heat taken in or released during a change of state. So the amount of heat energy that's taken in here and taken in here, for example, is what's known as what's called latent heat. So it's the heat energy taken in or released during a change in state. So this is like a graph for water, but you can get a graph like this for any other substance as well. And in order to be able to identify, for example, the melting point or the boiling point, it's this point here where you get the leveling off. So the first leveling off is going to be the melting point, and then the second leveling off is going to be the boiling point. Okay, so in this lesson we investigated and looked at the properties of different materials, including, so we looked at solubility, we looked at conductivity in relation to heat and electricity, we talked about what the melting point is and what the boiling point is as well. So thank you for listening.